Dear students, welcome to the engineering chemistry course once again. Today we are going to start the new unit, but before starting the new unit, just have the recap of the last unit we have learned. In the previous class, we have completed the unit 2nd, organic fuels. Basically, this organic fuel unit is divided into 4 major topics: solid fuel, liquid fuel, gaseous fuel, and the combustion based numericals. In the solid fuel, we have learned about the coal and the coke solid fuels in detail, and we have also discussed in detail the determination of calorific value by Bohm's calorimeter, Junker's calorimeter, and by Dulong's formula. Then we have started with the liquid fuels, in which we have discussed the mining and refining of the petroleum. Then we have learned about the cracking process in detail, and we have also discussed the synthetic petrol. After that, we discussed the knocking, octane number, anti-knocking compound, and the cetane number in the topic liquid fuels. After that, we have started with the gaseous fuel, in which various type of gaseous fuel we have discussed: natural gas, CNG, LPG, coal gas, and oil gas we have discussed in detail. After that, we learned about the combustion based numericals. Basically, in the combustion based numericals, we have learned that how to calculate the amount of oxygen and air required for the complete combustion of the fuel. And we have also learned to calculate the dry products of combustion in these kind of numericals. So that's all the topics which we have completed in the unit 2nd, organic fuels. In today's class, we are going to start the unit 3rd, corrosion. In today's class, we will focus on the introduction of this unit, disadvantages of corrosion, theories of corrosion, in which 2 theories will be covered in the today's class: acid attack theory and the chemical attack theory. So let us begin with the introductory part. The unit 3rd, corrosion, covers following topics: introduction and the definition of corrosion, disadvantages of corrosion, theories of corrosion. There are 3 theories given to explain the mechanism or the reason of the corrosion. These theories are acid attack theory, chemical attack theory, and the electrochemical theory. After that, we will discuss the factors affecting corrosion, types of corrosion, and the corrosion prevention methods. So let us begin with the topic corrosion. What is corrosion? Basically, any process of deterioration or destruction and consequent loss of a solid metallic material through an unwanted chemical or electrochemical attack by its environment at its surface is called corrosion. So basically, what corrosion is? Corrosion is the degradation of any pure metal or alloy by its surrounding environment, and it is always the unwanted chemical reaction. So basically, what we can write here: suppose any metal undergoes in environmental condition in presence of oxygen or any gas and converted into metallic oxide or its compounds. So if this reaction is unwanted chemical reaction, unwanted means we don't want to convert the metal into its metallic oxide. So if this reaction is unwanted, then it termed as the corrosion reaction. Let us take example in which in our laboratory we want to convert any metal with the reaction of oxygen into its metallic oxide. So if this reaction is carried out in laboratories and we aim to produce the metallic oxide, so this will not be considered as the corrosion reaction. Why it is not considered as a corrosion reaction? Because here we purposely want to manufacture the metallic oxide. So it is not the unwanted chemical reaction. But in normal environmental conditions, if any pure metal undergoes in oxidation or any type of chemical reaction due to which this metal gets slowly converted into its oxide or it's any type of compound, then this unwanted conversion is termed as the corrosion reaction. So here two things are very important. What two things? First, always remember corrosion is always the unwanted chemical reaction. Secondly, corrosion is always the exothermic reaction. Why it is the exothermic reaction? What is the meaning of exothermic here? Exothermic reaction means here heat energy is evolved in this reaction. Heat energy is also evolved with this reaction. So you must remember that corrosion is always the unwanted chemical attack. Secondly, it is always the exothermic reaction. So I hope it is clear to all of you now that what is the corrosion reaction. I am again repeating the definition here. Corrosion is the process of deterioration or destruction of any pure metal or alloy through unwanted chemical or electrochemical attack by its surrounding environment is the corrosion. Clear? It is exactly the reverse process of the extraction of the metal. Why? Because when we extract any metal from its alloy, we have to convert it oxide or the metallic compound to its pure form. So now in the metal extraction process, metal is extracted from its compounds and we have to supply the energy for this purpose. While in the corrosion, metal is get converted into its oxide and energy is liberated. So it is exactly the reverse process of the extraction of the metal. Now, what are the examples of the corrosion? In our daily life, the rusting of iron is the very common example of the corrosion. When iron is exposed to the atmospheric condition, a layer of reddish brown iron oxide, brown color iron oxide is formed at its surface. This is the very good example of the corrosion of the iron. Similarly, corrosion of copper. In the copper metallic structure, green colored layer is formed. What is this green colored layer? This green color is the basic carbonate layer. This is the example of the corrosion of the copper particles or the copper metal surface. Now, why we call it the unwanted chemical reaction? Because it has several disadvantages. We know that the process of the corrosion is slow and occurs only at the surface of metals, but the losses incurred are enormous. Destruction of machines, equipments, building materials and different type of metallic products, structures, etc. resulted due to the corrosion reaction. So many kind of disadvantages we have due to the corrosion reaction, and these all advantages results in the economic loss. The losses incurred are very huge and it is estimated that the losses due to corrosion are approximately 2 to 2.5 billion per year worldwide. So it is a great loss. Now coming towards the next topic, that is theories of corrosion. What is the meaning theories of corrosion? What it means? It means the explanation why corrosion takes place is given by three kind of mechanisms. These are called as the theories of the corrosion. So these theories are acid attack theory, chemical attack theory, and the electrochemical theory. The acid attack theory is the primitive theory given to explain the corrosion phenomena in presence of moisture, while chemical attack theory is the second theory given for the explanation of corrosion in absence of moisture, while the third theory, electrochemical theory, is the most advanced theory given for the explanation of the corrosion in presence of moisture, in absence of moisture, both. So let us begin with the acid attack theory. This is the first theory given for explanation given to explain the corrosion. This theory suggests that the corrosion of metal, basically it considered the iron metal. So this theory suggests that the corrosion of iron is due to the presence of acids surrounding it, and how these acids are in its surrounding, because according to this theory, some acidic oxide gases like carbon dioxide, sulfur oxides, and nitrogen oxide. According to the acid attack theory, some acidic oxide gases present in the metal surroundings forms corresponding acids with the reaction of the moisture in its surrounding. That means these acidic oxide forms corresponding acids due to the reaction of moisture in the metal surrounding. So if metal is present in this type of atmosphere where sulfur oxide, nitrogen oxide, or the carbon oxides are present, then these oxide in presence of moisture forms corresponding acid, and metal get corroded in presence of these type of acids. So basically in the acid attack theory, the acids are considered as the main cause of corrosion, and how these acids are present in the metallic surroundings, because in environment some acidic oxide gases are present. These acidic oxide gases react with the moisture to form the corresponding acids, and due to the presence of these acids in the metal surroundings, metal get corroded. So basically the acid attack theory focuses on the corrosion due to the acids. These acids slowly dissolve the metal. For example, here we consider the corrosion of iron in presence of carbon dioxide. Carbon dioxide reacts with moisture to form carbonic acid. This carbonic acid slowly dissolve the iron, and iron first convert into iron bicarbonate, then ultimately from this iron bicarbonate iron rust is formed. So the main cause, according to acid attack theory, the main cause of corrosion is the acids, and for the formation of acids, what two things are responsible for the formation of these acids? Moisture in the metal surrounding and the acidic oxide gases are responsible. So the main problem with this theory is that in absence of moisture it cannot explain the corrosion, because if moisture is not there, then acid will not form, and according to acid attack theory, corrosion takes place in presence of acids only. So this is the main drawback of this theory, that this theory cannot explain the corrosion in absence of moisture. So to overcome this problem, the second explanation was given, that is the chemical attack theory, which explains the corrosion in absence of moisture. That is why it is also called the dry corrosion. According to this theory, corrosion on the surface of metal is due to direct reaction of atmospheric gases like oxygen, halogen, oxides of sulfur, oxides of nitrogen, hydrogen sulfide and fumes of chemicals with the metal. That means, according to this theory, in absence of moisture also, some gases can directly attack onto the metal surface, and hence in presence of these type of gases, metal get corroded. In such cases, the extent of corrosion of a particular metal depends on the chemical affinity of the metal towards the reactive gas. That means, in such type of corrosion, when some gases can directly attack onto the metal surface, the extent of corrosion depends upon the chemical affinity between the metal and the attacking reacting gas. Generally, oxygen is mainly responsible for the corrosion of most metallic substances as compared to the other gases and the chemicals. So let us consider the chemical attack theory or the dry corrosion. In the dry corrosion, corrosion takes place in absence of moisture due to the direct attacks of some chemical. So, on the basis of the nature of the attacking chemicals in absence of moisture, the dry corrosion can be divided into three types: oxidation corrosion, corrosion by other gases, and the liquid metal corrosion. Oxidation corrosion takes place due to the direct attack of oxygen onto the metal surface. Corrosion by other gases other than oxygen, some other gases are also can directly attack onto the metal surface. So, corrosion due to these other gases is categorized in this. While third one is the corrosion of solid metal due to the attack of the liquid metal. So, this is known as the liquid metal corrosion. So, let us discuss one by one. First is the oxidation corrosion. The oxidation corrosion is due to the direct attack of oxygen onto the metal surface in absence of moisture. Generally, as we increase the temperature, the rate of oxidation corrosion is also increases. So, what necessary condition for oxidation corrosion? Only two things: presence of oxygen at the metal surrounding and absence of the moisture. So, let us consider this type of metal. If suppose this is a bulk metal, this is the metallic structure, complete metallic structure. When this metal shows the chemical reactivity towards the oxygen, then due to the presence of oxygen in its surrounding, the surface metal ion undergoes an oxidation reaction and converted into metallic cations. So simply, the oxidation taking place here, and at the surface of the metal atoms undergoes oxidation and forms the metallic cation. Suppose I am taking the bivalent metal here, and formation of the metal cation and the electrons are released. Now, due to the release of electron at the metal surface, these electrons attract the oxygen in the surrounding environment, and these oxygen reacted or capture these electrons and converted into the oxide ions. So, reduction taking place here. Clear? So, in the surrounding of metal, oxide ion is there, and at the metal surface, metallic cation is there. Both are having the opposite charges. Oxide ion are negatively charged, while metal cations are the positively charged. So, due to the opposite charge, these both are coming towards each other. Metal ion diffuses outwards from the metal surface, while the oxide ion coming towards the metal surface. So, near the metal surface, there is the formation of the metal oxide due to the reaction of the combination of the metallic cation. These metallic cation combined with the oxide ion and forms metallic oxide near the metal surface. So, finally, the completion of the reaction resulted in the formation of the metallic oxide onto the metal surface. Suppose there is the formation of the metallic oxide in this way at the metal surface. In such type of cases, in such type of oxidation corrosion, the extent of corrosion further depends upon the nature of this oxide layer, what type of this oxide layer is. So, further corrosion depends upon the nature of the metal oxide layer. It may be stable layer, unstable layer, volatile layer, or the porous layer. So let us consider one by one. First is the stable layer. If metal undergoes in oxidation or metal undergoes corrosion in presence of oxygen, and there will be the formation of the stable metal oxide layer. So once the metal oxide layer is formed onto the metal surface, it completely covers the metal surface. So it protects the metal surface from the further attack of oxygen. Now oxygen cannot come into the direct contact of the metal atom because there is the barrier of the metal oxide stable layer between them. So this stable oxide layer will protect the metal surface from the further attack. So in this case, what happens here? In this case, metal get protected and further corrosion does not take place. Such type of layer is formed generally in case of aluminium, tin, lead, and the copper metal. So first time attack of oxygen takes place, and after formation of the stable oxide layer, further no corrosion takes place. Now, second case is the formation of the unstable layer. In such cases, metal undergoes corrosion and formation of the metal oxide layer takes place. But the nature of this metal oxide layer is unstable, means as the oxide layer is formed, it soon decomposes again into the fresh metal and the oxygen. So this is the reversible reaction. Metal reacted with oxygen to form metal oxide, and at the same speed metal oxide decomposes to the metal and the oxygen again. So as a nutshell result, corrosion is zero. Why zero? Because the metal oxide also decomposes in the metal and oxygen with the same rate at which metal combines with the oxygen. So net result will be the zero. For example, in case of silver, gold, and the platinum. Third case is the formation of the volatile film. If metal undergoes corrosion and metal oxide formed onto the metal surface, the nature of the oxide layer is volatile. That means as the metal oxide is formed, soon it get evaporated. So when metal oxide layer is evaporated, then next fresh metal surface is exposed to the further attack of the oxygen. So next layer will be oxidized, and as metal oxide is formed, this metal oxide is again evaporated and further next fresh metal layer is exposed to the metal. So in such cases, complete metal get corroded. For example, in case of molybdenum, volatile oxide layer is formed and the complete metal get corroded. Now, fourth and important is the porous layer. What is the word porous means? Porous means the metal oxide layer is not covered the complete metallic surface. In some places there is the metal oxide formation takes place, while some places no metal oxide is formed. So this is the case where metal oxide layer is the porous. That means in some places oxide is there, while some places are directly exposed to the environment or the oxygen. In such case, further attack through pores or cracks continues till complete corrosion of the metal takes place. In such cases, metal get completely corroded through these pores. And for example, in case of lithium, sodium, magnesium, potassium, etc., through these pores metal get completely corroded. So this is the example of the porous layer. Now, one thing we now understand that in the oxidation corrosion, further corrosion or the extent of corrosion is highly dependent on the nature of the oxide layer formed. So, for the explanation of this, the Pilling-Bedworth gave the rule which is known as the Pilling-Bedworth rule. According to this rule, first let me correct one here. According to this rule, further corrosion of metal depends upon the Pilling-Bedworth ratio. Now, what is Pilling-Bedworth ratio here? Pilling-Bedworth ratio is the ratio of volume of the metal oxide formed to the volume of complete total metal surface. So, PB ratio is what? PB ratio is the ratio. What is the PB ratio? PB ratio is the ratio of the metal oxide, total volume of the metal oxide divided by the total volume of the metal, right? So, let us discuss if PB ratio is less than 1. In such case, if PB ratio is less than 1, what it means less than 1? Less than 1 means there is the less amount of metal oxide and large amount of metal, complete metal volume. So the layer formed will be the porous layer and the layer is the non-protective layer. In such cases, metal undergoes in the corrosion at the faster rate. So in such cases, metal undergoes in corrosion at the faster rate. So let me correct here. It is the typo error. And metals undergoes corrosion at the faster rate. Because it is the porous layer. Clear? While in case PB ratio is greater than 1, greater than 1 means large volume of the metal oxide layer will be there. So in such case, the layer formed is the non-porous layer, and since it is the non-porous layer, so it covers the complete metal and form the protective layer on the metal surface. So in such case, further corrosion does not take place. So if PB ratio is less than 1, the protective layer is the porous layer and it is the non-protective layer, and in such cases corrosion takes place at the faster rate. While if PB ratio is greater than 1, in such cases layer is the non-porous and the protective layer, and metal surface, for corrosion of the metal surface does not take place further. So it must be clear to all of you, if PB ratio is less than 1, corrosion takes place at faster rate. If PB ratio is greater than 1, corrosion further does not take place. So I hope it is clear to all of you. Now, corrosion by other gases. Other than oxygen, some gases may also cause the corrosion, but in presence of other gases, the corrosion depends upon two things. First is the chemical affinity between metal and the gas. That means the gas and the metal shows the chemical affinity. That means there is some reactivity between metal and the attacking gas. If the chemical affinity is there, then extent of corrosion depends upon the nature of the corrosion product formed onto the metal surface. For example, here two metals we are taking, tin and the silver. Both metals shows chemical affinity towards the chlorine. That means in presence of chlorine, silver and silver and tin both get reacted and undergoes corrosion. But extent of corrosion depends upon the nature of the film formed. Here silver chloride is formed, here tin chloride is formed. But the layer formed of the silver chloride is the non-porous layer. That means it is the protective layer. While tin chloride layer is the volatile layer. That means complete tin get corroded in such cases. Similarly, iron get corroded in presence of oxygen, we have just now discussed, while in presence of H2S it also may get corroded. Why? Because iron reacted with the hydrogen sulfide easily and forms the iron sulfide porous layer, and due to its porosity further corrosion takes place at the faster rate. So in presence of these gases some metals also get corroded. Now the other example, third one, is the liquid metal corrosion. That means a solid metal undergoes in corrosion in presence of liquid metal. Suppose this is the solid metal. It is in contact with the liquid metal. So due to this liquid metal, corrosion of this solid metal takes place. This is the example of the liquid metal corrosion. Due to the action of the flowing liquid metal at high temperature on solid metal, the corrosion of solid metal takes place. This is the best example of the liquid metal corrosion. In such cases, the extent of corrosion depends upon two things. First is the dissolution of this solid metal into this liquid metal. Second thing is the internal penetration of this liquid metal into solid metal. These two factors determine the extent of corrosion in case of the liquid metal corrosion. What these two factors are? First is the dissolution of this solid metal in this liquid metal. Second, penetration of this liquid metal into the solid metal. The best example of liquid metal corrosion is observed in nuclear reactors, where sodium metal used as a coolant leads to the corrosion of the cadmium pipes in which liquid sodium is flowed. So this is the best example of the corrosion of solid metal cadmium in presence of liquid metal sodium. So let us revise what we have learned or discussed today. Today we have started with the unit 3rd, corrosion, in which we have learned the definition of corrosion, disadvantages of corrosion, then the important feature of this unit, theories of corrosion. We have started with two theories of corrosion we have learned today, acid attack theory and the chemical attack theory. In acid attack theory, we have learned that acids are considered as the main cause of corrosion, and these acids are present in the surrounding of metallic environment due to the presence of the moisture, and this moisture reacted with the acidic oxide gases in the environment. So the main drawback of this acid attack theory is that in absence of moisture it cannot explain the corrosion. While we move towards the chemical attack theory, which is also called the dry corrosion. According to this theory, in absence of moisture, some gases can directly attack onto the metal surface and causes the corrosion. That's why it is also called the dry corrosion, in which we have learned three types basically. Oxidation corrosion, in which corrosion is caused by the attack of oxygen on metal surface. Then we have discussed the corrosion by other gases. Besides the oxygen, some other gases like chlorine, H2S can also attack on the metal surface and results in the corrosion. Third category, we have discussed the liquid metal corrosion, in which solid metal get corroded in presence of the liquid metal. That's all for the today's class. Please read the question, pause the video and think about the answer of this question. Silver and tin are in the chlorine environment. Which metal corrode faster and why? Think for this question and we will discuss its answer in our next live class on Tuesday. Till then, take good care of yourself and keep enjoy e-learning at home. Thank you.